Hello, I'm Robert Rosenberg. I'm giving a workshop on live sound. I call it ringing out the system because ringing out the sound system is a crucial component to getting good live sound. The problem with live sound is feedback. Feedback is when the speaker puts out a sound, the microphone picks it back up again. It gets amplified through the system, comes out the speaker and gets picked up again, and causes a loop that usually ends up in a squeal or a rumble uh, or something you don't want. In recorded sound, you don't have that problem. You don't have speakers, and you can also often post process something. You can also if you wanted to add a little bit more bass to the tone of somebody's voice or a little reverb, you can do that after the fact in recorded sound. In live sound, you have to do it you have to do all your improvements before they happen, because once they happen, it's out there and the show is damaged. Ringing out the system is the process in which you cause feedback, hopefully before anyone gets there, before the audience gets there, or even the band gets there. Once you set up the system, it's all the mics are on. You purposely turn the volume up to cause feedback to find out where the offending frequencies are going to be. That can be and the reason there is offending frequencies is could be caused by many things. I want to give this talk because I've experienced lots of bad sound going to concerts. I play music. I often have trouble with sound. I want people to understand that it's not that hard. There's only two things, volume and frequency. And often the sound engineer maybe can dial in the front of house okay, but, where the audience sits, but often doesn't hear what's going on stage. So you need to be able to talk to the sound tech and say what you need. So I'm going to try to give you the tools to do that. We're going to discuss speakers and mics because their placement is crucial. We're talk about the two things, volume and frequency. There's only two things. All we're doing is changing the volume of certain frequencies. We're going to ring out the system to get headroom. Headroom is the distance between listening level, which I don't know if you can see me, but listening level, let's say, is here, and the point of feedback is here. That's headroom. You've got room to turn up the microphone. If, let's say, the singer says, "I need a little bit more of me in the monitor," you can turn them up without hitting feedback. Without getting feedback. If that feedback level is down here and comfortable listening level is here, well, then you have to bring down the level of listening to the point where it's not going to feed back and things are going to get lost. Then when we'll talk a little bit about trying to, how do you achieve this natural sound? Because that's our goal. We want things to sound as natural as possible. Mics and speakers. Speakers, two main purposes of speakers. One is for the audience, and the other is for the band. The band speakers are called monitors. They're often the problem because the monitors are so close to the microphones. The main speakers are the ones that broadcast to the audience. And you want to place them far enough away from the microphones that they are not going to get picked up, that the sound from the speakers are not going to get picked up by the mics. Now, to know where to put them, you have to know the dispersal of the speakers and the reception of the microphones. Most speakers have a 90-60 broadcast. In other words, they broadcast 90 degrees left right and about 60 degrees up down. So you want to place the microphones in a place where the speakers are not projecting, away from that cone of projection. Now, speakers are often main audience speakers are often called front of house or mains or left right. Monitor speakers are called wedges sometimes, but we'll call them or auxes. Some channels they're listed as aux, as an auxiliary. Microphones also have a pattern of pickup. This is an example of an omni pickup. These are heads. They look like little black dots, but they're heads. They aim toward the center. That is the microphone. Now, in an omnidirectional mic, it picks up everything 360 degrees, and it's you can't have monitors because they're going to pick up the sound. The microphone is going to pick up the sound of those speakers. So most microphones have a cardioid pattern where they reject what's behind and only pick up what's in front. The mic I'm using currently is a supercardioid, which rejects often to the which rejects to the side and has a little rejection behind, but most of rejection is to the side, and so it's a good. So speaker placement should be at an angle from the microphone. I want to mention phantom power here because often you set up a microphone and it doesn't work, and it's because it's a condenser mic and it requires phantom power. Phantom power is not all microphones require phantom power. It's only the microphones that need a preamp boost. Now the way a microphone works and a speaker works in reverse, but the way a microphone works is there's a diaphragm with a permanent magnet. When you pass a magnet through a coil of wire, you generate a voltage. Now, if that the diaphragm is very sensitive to human or to sounds and can replicate them with voltages very well. So there's a very low voltage that comes out of the microphone and into the mixer, which has a preamp, which boosts the signal because that signal is so weak you couldn't even hear it with headphones. It boosts the preamp boosts the signal to a line level, and then it gets mixed, and you can do lots of other things with the mixer, and then it eventually gets amplified and out to the speaker. So the mixer has a boost preamp, and you have to set that level to where it doesn't clip, doesn't go into the red. We'll show that when we set up the system. The mixer does lots of things, especially mixing, getting all the microphone levels to be at the proper volume compared to each other. But they also, you have the ability to increase the bass, tone controls, a little, or EQ, equalization, which is the same thing as tone controls. You can boost the bass, you can cut down the mid-range frequencies. You think of frequencies as pitches. So if you have and you want that to be less, you can turn down the bass in a mixer. Most of those knobs, or at least I'm not sure, I can't read this, but I think these 3 knobs are probably bass, mid-range, and treble. And it gives you tone control for each channel. But you also have tone control for the whole broadcast of all the microphones put together, a tone control of the mains. Because remember, there are only 2 things. We're just going to change the volume of various frequencies. Frequencies can be thought of as pitch. Sometimes there's a separate EQ, and sometimes, but most mixers have the basic functions of bass, mid-range, and treble. And the last component of our sound system are speakers. And there are 2 kinds of speakers, basically, passive speakers and active speakers. Passive speakers require a separate amplifier, which is often in the mixer, embedded in it, which makes it heavier, or a separate heavy box that you put in a rack. And active speakers are speakers that have an amplifier built in them already. Active speakers require electric power to them. That's their downside. The upside is they're simpler to deal with because you don't have to have a separate amplifier. Now, there are two things: volume and frequency. Volume, you're familiar with. Speaking level is about conversation. Typical conversation is probably around 40, 50 dB. I'm probably talking 60 some dB. I'm talking a little louder than conversation. Jet engine is like 130 dB. It's measured in decibels. Um, when you go to a concert, you typically want the nice listening level is like around 90 dB. When it gets to be 100, it's it starts to hurt me at least. It's a logarithmic scale, so it's 90 is the difference between 90 and 100 is a lot more than just 10%. So you can get a decibel meter on a phone and a sound pressure meter and see what and adjust the level of a live sound concert according to that. Just don't let it go 90 for prolonged periods. It can hit that and then go back down, but um, you can after about 100, the long term starts to hurt. Frequency you may not be as familiar with. Frequency is is in hertz, also known as cycles per second. Now, the human ear has a range of hearing that's between 20 hertz and 20,000 hertz. So my my conversation is probably in the area of 200 hertz. When you get to be at 20 hertz, it's so low you can't hear it. I don't have a bass here to demonstrate, but it's a bass is probably like 50 hertz. And it starts after 20. It's too low to hear. 20,000. Most people lose that high end at above 17,000 as they get older. Not many people hear those. Um, so that's the range of human hearing. It's important to know because some of these frequencies that are so low, we're just going to get rid of because they're only going to cause problems and they're not going to enhance the sound. If our goal is to get natural sound, then why do we have to fuss with all these knobs and tone controls? So the reason we have to do this is because of the equipment and the room. The equipment may accentuate lower frequencies. The room may accentuate mid-range frequencies. And so to achieve natural sound, we have to remove these elements that are making it unnatural. Okay, so if we plug things in, I'm going to be demonstrating with a Mackie DL16S. These are input channels, and there are 16 of them. These are output channels. So the microphones get plugged into here, microphones and instruments, with either XLR cables or sometimes 1/4-inch cables down in the bottom row. And the speakers get plugged into here. Generally, generally you would plug your mains into the left right into these two. And your monitors are in these aux channels, auxiliary channels. The next thing we'll do, and I'm going to go through what we're going to do and then we'll do it. But the next thing you do is you set the input gains. Now, remember I said the microphone puts out a very weak signal and the mixer has a analog preamp to boost that signal, a little amplifier. We're going to talk as loudly as as we're ever going to speak into the microphone and set our preamp levels, our gains, our input gains based on our loudest volume. If at a sound check we speak very softly or play very softly into our microphone during the sound tech may boost our preamp signal that to a good level of listening. But then when we start getting loud, we're going to go into the red, and that will be an indication that we're distorting the sound. So it sounds bad. So when you do a sound check as a live musician, you want to play as loud or sing as loud as you're going to sing, and then set everything to that level, and then to avoid clipping, distortion at the high end. The last thing you do is turn on the sound, turn on the speakers. Now, so at a sound check, the sound technician might say, "Sing as loud as you're gonna sing," and you say, "Well, I don't hear anything." Well, that's because the speakers aren't on yet. It's all we're doing is getting the level. All we're doing as the sound tech is looking at lights to make sure you're not clipping. After when the amplifier is the last to come on and the first to come off. So what we're going to do is we're going to ring out the system. I'm going to bring up a screen that looks like this, and it's on the x-axis is the frequency from 20K to 20,000K. I mean 20 hertz to 20,000 hertz. And we're going to turn up the volume to where it starts to feed back, and we're going to hear this a feedback, and we're going to see in a real-time analyzer, this RTA, that this frequency is maybe going to start getting loud. So we'll turn it down to the point where it goes away. That will give us more headroom. So on the x-axis we'll have frequency, and on the y-axis is volume. So we'll be turning up and down frequencies, usually down, the offending frequencies. You got that? And then the last thing we'll do is try to achieve natural sound. Okay, so I'm going to pause the recording to set this up. And it's not going to sound as good by the time I'm done.